which explains why I couldn't find it anywhere, by the way.
Yeah.
So we're really late. But we might as well jump right into to it. Welcome back to Future Tech, your weekly source for latest in tech and innovation and business. And I'm the startup coach. And with me, as always, I'm joined by my co-host John Irwin. How you doing today, John?
Good, Craig. How are you? It's a little rainy out there today.
Yeah, we had a false start with StreamYards this morning, so this is take
Yeah.
two, but we might as well jump right into it, where we're breaking internet speed records
Yeah.
like by a factor of 4.5
Yeah.
million.
So it's really cool. So a new world record was set. With the previous one was in 2020. And this was set for internet transmission speed. So researchers from Aston University in the UK were part of an international team that achieved an internet speed of 301 terabits per second using standard optical fiber. Now, just to put this into perspective, you said it's 4.5 million times faster than the average broadband speed. Um, to put that into further perspective, at 301 terabits per second, you could essentially download every single movie that's listed on IMDb in about a minute, which is crazy. Obviously, you're getting into read and write speeds limitations and things like that, but theoretically, yeah. And the way they accomplished this was developing a new optical processing device that takes advantage of previously unused wavelength bands in fiber optic cables. So now they're utilizing E band and S band. And they were currently, I guess, not previously, but currently, I think it's C and L band that are used. So the new bands provide a potential vast increase in transmission capacity through a single fiber. And the way that they did this was by breakthroughs in optical modulation and multiplexing techniques that allow packing many more data channels into a single fiber strand. So some of the key innovations included programmable frequency combs and parallel single sideband modulation. So the thing is you're not going to see these record-breaking speeds, and we don't really need them yet. But as technologies like AI, VR, autonomous vehicles that rely on fast, robust data transfer become more and more common, we're going to need this backbone fiber network with this upgraded transmission speed in order to handle all of that data. Now, does that mean that the consumer is going to get that fiber speed to their house? Potentially, but as we've covered before, maybe we haven't. Wireless transmission speeds are getting up there too. Now, again, we can talk conspiracy, and we're talking more RF signals in the air and all that sort of stuff. But at least we have a breakthrough in fiber technology if we get away from the RF, which I don't think we ever will.
Yeah, this looks really interesting. Sorry. I see this applying more to the back end than to the home, so we could actually potentially start actually getting true gigabit Ethernet or internet to the home, where the back end could have terabyte connection speeds, so that we could get our home speeds actually faster. Maybe not these speeds, but performing at a decent level.
Absolutely. Yeah, definitely. And I'm hoping that it's true. I should do some more research on the actual frequencies and how they're able to transmit them through the fiber. So those that don't know, the way that fiber optic works is it works on light transmission. So you literally have strands of glass that is what the fiber is made up of. And you have on each end, you have a mux or demux on each end that will transmit pulses of light. And that's how your data gets transferred. Obviously, it's a lot more complex than that, but that's just so that those of you that don't know how fiber works. And so we do have a robust, like all the cables that are undersea, those are all fiber cables and things like that. So I'm hoping that they don't have to replace those. And if we are, then hopefully, if we don't have to replace them, then hopefully it's just investments in new routers, switches, multiplexers, all the hardware itself, instead of the actual fiber network.
Yeah, and the network interface cards, the next,
Yeah.
like when the servers are going to have multiplex NICs into redundant switches to perform at any level. But like right now, that's great. Okay, so we can upgrade the fiber. We can, with some hardware that doesn't exist today, upgrade the network interface cards and the backbone of all these switches that like have to be, if the interface is terabits, the backbone's going to have to be petabits.
Yeah.
So it's crazy.
Yeah.
But what's the average hard drive speed right now?
I don't even know what it is.
100
And we're
100
we're
megs,
talking
200
more.
megs per second?
This would be more SSD than hard drive, right? Because the
Yeah, but,
SSD, yeah,
and I'll Google that right now, but I'm just saying that,
yeah,
um, what do you do as a consumer? Okay, you can download 9,000 HD movies in a second. Um, you got nowhere to put them. Like, how does this change all the game? We talked about petabyte storage on those optical discs, which are years away, but
yeah.
those are going to be way slow.
Those are
What
super slow. Yeah.
what hardware needs to be upgraded to get us to a level where we can
Yeah.
actually accept this kind of performance?
Well, yeah, not only the hardware, but all of the buses and everything. And sorry, buses are like the communication channels for those that don't know. Um, for the hard drive with the computer with the NIC. So there's a bunch of things that are going to have to be upgraded in order to handle these speeds. I don't even know what the fastest SSD can handle right now, but um, there's going to need 20 megabytes. So 20 megabytes per second to 550
200,
megabytes.
200 to 550. Yeah.
Yeah, and that's megabytes, not bits. So
Yeah.
that's higher. So,
And it
but yeah,
says a typical is 80 to 160, but the SSD read and writes between 200 and 550. I can run a speed test shortly on my new MacBook M3, and I can tell you what its throughput is in a bit while we're doing this. But that's nowhere near the gigabit connection we have right now. Never
no.
mind, like I'm on a gigabit connection to my Switch here, which is on gigabit connection to Kojiko. But my download speeds won't be anywhere near that. And my computer can't handle it once it gets in. How many years are we going to be to the point where we can handle a terabit? Never mind 301 terabytes.
Well, just to put that into perspective, though, so they're giving it to you in megabytes, right? And we're talking terabits and bits, right? So if we were to convert that 550, or let's say 500, or that 550 to megabits, we're talking 4,400 megabits. So it's still a long ways away. But if we're talking, we just got to talk in the same kind of transmission. So
Well, according to this, if I have this right, a 550 megabyte
yeah,
equals 0.000
four
sorry.
four.
Yeah,
Yeah,
there's I threw an
which
extra
is
zero.
4,400 megabits. That's the equivalent. Because if you move
Well,
the
that's not true because we're doing 100. It's not divided by 1,000 because it's bits. It's a 125,000 or something. It's because it's 1,024, right?
yeah,
It's not a round number, so it skews.
yeah, it's off. But yeah, but
Uh,
anyways,
yeah. So my point being is we're at a magnitude that we can't even handle that. Like I've got
no,
256, you might get a terabyte hard drive. So what point are we going to, like, this stuff we're going to see come anywhere close to being able to perform at that level? It's great that visually stuff can come in, and maybe it'll help with VR and the metaverse and whatnot once we've got everything. But what level do our hardware, how much faster does our hardware have to be able to handle that input? Not only hold it
yeah.
coming in, but process it and deal with it.
Oh yeah, we're gonna need it's like I'm talking like probably 100,000 times faster in order to handle this. But that's just me
Yeah.
guessing. Yeah,
So we're hoping this will hit the back end. That it'll be server farms, telcos, whatnot. Again, I implemented this back end stuff for companies like Bell Mobility. So we're not talking about small companies. So this stuff is gonna be millions and millions of dollars of upgrades for the high-end equipment. So, do you see how quickly we're going to be able, maybe not to get to this theoretical speed, but you said the last test was 170
Yeah,
terabits.
I think that's more. Well, that's even ridiculous. But like,
Yeah.
I think that we're going to slowly get up there. So I think that this is maybe 3 or 4 upgrades away. I think hardware upgrades away. But who knows? Like, I'm going based off of history, right? And if if we're looking at it, things are advancing quicker than they used to back in the day. So maybe it's not 3 or 4 hardware upgrades away. Maybe it's 2 or 1. I don't know.
Yeah, so we have to understand, like we're talking about the cable, and whether we'd have to really upgrade the cables or not.
Yeah.
Broadly speaking, the data sent via optical cable, like a home or office internet
So then,
connection.
yeah,
So
apparently they figured it out. So
it says
so we don't need to
broadly
upgrade the
speaking.
fiber.
So
Yeah.
yeah, I don't know. We might need a new category of fiber for this. It's hard to say.
Yeah.
Um, because you're saying it uses these new bands, and we don't know what the refraction level is on any of those. Um, do you think we're reaching the optical physical limit of current fiber technology? Or you think there's headroom to go way higher than this?
I think there's still potential to push it even higher in the future. Um, so we can continue to incrementally improve the spectral efficiency through techniques like more advanced modulation formats, better forward error correction, increased spatial multiplexing, and tighter channel spacing as we upgrade components. So as we see progress in lasers, modulators, amplifiers, filters, switches, processors, for example, moving from CMOS to photonic integrated circuits, multi-mode fiber, multi-core fiber, new bands, non-silica fiber. So transitioning from silica glass to polymer or hollow core photonic bandgap fibers can definitely lift those limitations on latency and loss and things like that. And then, like we talked about, in order to handle this stuff, optical computing. So processing data directly in the optical domain instead of converting that. So that's going to be key as well. So while 301 terabits is super fast, they're continuing. I feel like they're going to break that in the next year or two, even maybe.
Yeah, like it says here, the ability to increase speeds while deploying new fiber and cables also makes it a greener way to upgrade a commercial internet speed. So the plan is to use as much of the fiber that's out there as possible by increasing the transmission capacity. So they're planning on using this technology, whatever it is, and putting it in the NICs and the switches um, to get that moving. And they talked about in the article about the backbones, having built multiple data centers, it's the backbone that really needs to happen. So you're going to start seeing servers with 4 or 8 or dual 4 multiplexed
Yeah.
fiber channel networking cards running into multiple servers to start getting this kind of speed.
Yeah.
This is groundbreaking. We have some of the highest internet costs in the world.
You do.
Is this going to
Internet
release?
and cellular. Yeah.
Or is this going to reduce our costs in Canada? Maybe.
No, it's just a way for them to charge us more, faster speed, pay more. All we had to do was buy some new hardware, but hey, pay more.
Yeah. So this looks like it's going to be expensive upgrades on the networking centers for
Yeah.
their backbone hardware that runs the internet.
Mhm.
We got to move on to the next one. This is incredible. I love anytime we can increase our internet speed. Any final words before we move on?
No, this is interesting. I'll be interested to know when the next world record is broken. So
All right. This next article, we're talking about wireless light switches and how they could cut house wiring costs in half. It's a little complicated to say that.
yeah, no, it's really cool. So this is cool because it's a Canadian invention. So the article that we're talking about from U Alberta discusses an innovative wireless light switch, which was developed by Professor. Oh, I hope I don't mess up his name. Cambias Moez. at the University of Alberta, and it operates without batteries. And the way it does that is by harvesting ambient radio frequency, so like RFID, things like that. So his switch eliminates the need to run wires from each switch to the connected light fixture, which could reduce home wiring costs by up to 50%, according to Moaz. So the switch consists of a wireless transmitter that can be installed anywhere on a wall, and an RF power transmitter placed on each floor of the home to provide the power to all the switches wirelessly. So we're talking kind of wireless power, but not really, because it's just RF. So he's already created a working prototype switch for under $1. And apparently the technology is scalable, customizable, and easy to install based on his design. And it was approved for use in Alberta homes in actually 2018. So, in addition to cost savings, the wireless approach enables smart home applications like occupancy sensors, automated lighting, and climate controls, and different things like that. So, yeah, it's really cool. If commercialized, the Switch could be a boon for home builders and consumers seeking affordable smart home upgrades, as well as reducing the cost to build new homes. So really, really cool stuff.
Yeah, and I was wondering about the cost, but it looks here he's developed a prototype switch for less than $1 that can be installed anywhere on a wall. The switch
Yeah.
is scalable, easy to replicate and adapt. So it sounds like it'll be not necessarily more expensive than existing solutions. I guess the question is the switch has got to talk to something. It's always nice to say, "Oh yeah, the switch is really cheap with this whatever it is with the that sucks
Mhm.
static electricity out of the air and ambient energy and works." Um, what's
Yeah.
it
So
connect to?
there's a couple things. So it connects to an RF power transmitter. So I'm guessing it's like a bridge kind of thing. Um, I don't know, but like obviously you're gonna have to interoperate with smart home technologies like Wi-Fi, Bluetooth, Zigbee, um, Apple Home, which I don't like, and all other ones. But there's a couple things here to think about. So the RF power transmission, it may raise concerns about exposure safety. Obviously, he's going to be compliant with FCC and health regulations and things like that. But the other thing too is, although no batteries is useful, the RF power transmitters would still need a continuous power source. So backup battery for power outages would be pretty much a staple would be needed in this. But again, if the power's out, how are you going to turn on your lights and things like that? But it could be this is more around other technologies that could utilize this concept, if that makes sense. I think you're on mute.
Sorry, but this looks amazing. I love the concept. We just don't know how the cost of those things. And then are we going to need like we're talking about saving wiring costs? Are
Yeah.
the light fixtures and the furnace or whatever? Because we talk about you can do temperature, heat, and humidity, and do a bunch of different stuff here. Are they all going to have to be wired in, or are they going to have somehow a wireless sensor that connects as well?
Well, no, they're all going to need to be connected to power, unless we
Yes.
get into wireless power transmission, right? Which is
Wha
even crazier.
Absolutely, but do they need to be wired to a switch somewhere that turns them on and off that works with this?
I think so. I'm trying to think how this would work. So the lights would have so they probably all need an adapter, or they would have to have something built in. It makes sense because obviously you need a two-way communication, right? So you need some sort of chip or something that could handle that. So maybe it could be that like you get a new fuse panel that integrates all of this
Yeah.
potentially.
Yeah, there's a lot of
Uh,
things you could potentially do. I'm just trying to out of the box, you're excited about it, but then you're like, "Okay, what can I really do with it now?" It's like, not much." But new homes, like,
New home,
if you can get rid of significantly, a lot of that copper, which is really expensive now,
yeah,
and hook all this stuff up wirelessly, never mind some of the things it's saying here where, you can have it automatically open and close heating and cooling vents for you if you're not in those areas of the houses.
yeah.
Um,
This
so
comes back to that movie. I don't know if you saw the movie Antitrust. It's kind of based on Microsoft, but it was cool because the guy who was the head of the company, Stars Ryan Felipe. It's really good. You should watch it if you have it. It's old, but it's in the 90s. But what happened was whoever would enter a room, it would change the art based on their profile and things like that. So this could potentially enable that as well. Obviously, right now you could enable that by wiring, but if you want to build it into current homes, this would help too because it's wireless, right? So you could figure out how to. I'm sure there's a way to retrofit.
Yeah, I think I remember that movie. I know that Bill Gates had a painting like that. I'm going to say a painting, a monitor like that looked like art that changed with their mood or whoever was in the
Yeah.
room and whatnot. So it was interesting. I remember seeing at least that scene in the movie. I don't remember the rest of it.
Yeah.
But like it says here, imagine heating a 3,000 square foot house, but you're only in one room at any given time. If your house wirelessly controlled events, you can close events outside the room or maybe a couple of bedrooms. Could seamlessly turn this. We all see those in movies where you walk from room to room and it shuts the stuff off behind you and lights it up behind you, and eventually that becomes a
They actually,
horror
believe it
scene
or
like
not, that technology,
exists.
it's sensors, but like that's huge in Europe. They're all about that in Europe. Every building has that. So like even residential buildings, everything has that, and they've had that for years. And that's just using a sensor when you walk into a room, right, with a timer. But this is more like tracking you kind of thing.
Yeah, there are a few buildings in Toronto that have this type of technology that are more modern. I remember visiting Cisco a few years back, and they had sensors everywhere. If there wasn't anywhere in this area, they would start shutting things down automatically, and it really had this. They were in a smart building that had all sorts of interesting stuff. So, it's great to see this, but I think we're way behind what they are in Europe because we're so spread out.
We are.
It's hard to.
But like, it's it'll be interesting to see who adopts this first. It looks like Alberta, obviously, but see how far that gets adopted. But I think that there's great potential for this, especially for retrofitting as well. So, but there's obviously some concerns, right, as far as like potential reliability. So the wireless systems could be prone to interference, connectivity issues, just like your Wi-Fi, right? So there could be range limitations, the power sources, the complexity, like we talked for retrofitting, compatibility, load control limits, whole bunch of different things.
Yeah, of course. And you talked about retrofitting. What are the options for putting this into an existing home system?
Yeah. So, like the thing is it should be able to integrate with existing mainstream home automation systems. So we talked about Wi-Fi and mesh networks, smart home platforms, Zigbee, Z-Wave, IFTTT support. That's if this then that. Hub integration, cloud APIs, AI. It's all about the hub, right? So this switch, it's just essentially an interface. Like it's like an on-off kind of thing. Where the connectivity is going to come in is in the hub that he builds or how that integrates, right? So it's really cool.
Yeah, we got some comments here that I was missing because we had some technical lists. I'm just getting into wiring now. I've never even considered product cost. So this is cool. Thank you, LinkedIn user. Super cool. Glad to be here. Glad to have you. Seems natural since solving for functionality is the first applicative step. Yeah, this is great. I love this the concept, and it looks like we're moving into more and more like the fact that they're no battery is the kind of the key that triggers all this.
Exactly. Yeah.
Any final words before we jump to the next topic?
No, I think love that this is a Canadian-based project. Let's just hope that he's not hindered by our crappy Canadian investing system that we have here and limitations that the government puts on.
Well, I anybody who's significantly smart will go to the US if they're not getting the support here. So we'll see that's what happens, and then we lose the brain drain and we lose the IP.
For sure. Yeah.
So speaking of Canada, this next topic is concrete that melts ice and snow,
This
but
is,
without shovels and stuff.
yeah.
It just melts it.
And without forever chemicals, PFAs, without anything really extreme. So this article talks on a new type of phase change concrete, and it was developed at Drexel University. It can melt snow and ice without using salt or external heating, which is cool. The way that they do this, all they do is they've incorporated paraffin wax, and it acts as a phase change material. So what it does is it absorbs heat as it melts from solid to liquid around 42 degrees Fahrenheit. I don't know what that is in Celsius, but as temperatures drop below freezing, then the paraffin releases the absorbed heat, preventing the concrete temperature from dropping below 32 Fahrenheit, which I think is 0 Celsius. Um, so in outdoor tests, a 30-inch concrete slab with paraffin wax maintained temperatures of 42 to 55 Fahrenheit for up to 10 hours, which melted 1 to 2 inches of snow without any salt or heating. So the way that they did this was it was incorporated, the paraffin wax was incorporated into the concrete in two ways: absorbing it into the porous, lightweight aggregates and encapsulating it in microcapsules. So the lightweight aggregate method sustained heating longer for about 10 hours, while the micro-encapsulated paraffin heated up quicker, but only for 5 hours. So again, they're still testing different things, but by preventing the concrete from ever dropping below freezing, what it does is it avoids the freeze thaw cycles that damage the concrete and causes those cracks and things like that through expansion and contraction. The other thing is the self-healing mechanism allows the concrete to passively melt snow and ice without any external energy input, plowing, or environmental harmful salt. So those of you, you might see driveways right now where you see a concrete driveway that has no snow after a snowfall. How they do that is just pumping hot water through. So it's a heated driveway. This would eliminate that. That would eliminate the need for that infrastructure.
So, or we say, I'm looking at this, it says, which is great. Researchers found that phase change concrete maintained a surface temperature of 42 to 55 degrees Fahrenheit, which is 5.6 to 12 degrees Celsius, for up to 10 hours when the air fell
Yeah.
below freezing. So here we are in Canada where it's below freezing for months at a time. Um, like, is there any hope?
Well, here's the thing, right? So they're testing it at temperatures that are way above what we would see. And I didn't see anything in here that speaks to anything below those temperatures. So I would be really interested to know how cold the temperature can get and how effective the paraffin wax concrete would actually still work. But like we're talking like minus 20, minus 30 Celsius.
Yeah, this is the question. Like, it's great. They do all these studies uh, in places where the temperatures are normal, where they don't have, winter 8 months of the year or whatever we have it 6 months of the year here. So that like the Tesla batteries and EVs don't last as long. We're not sure about this, but the concept is really cool. Like self-heating concrete being suitable for mountainous and northern regions in the U.S. and Northeast Pennsylvania. We've all driven. Well, I've driven through a lot of those winding mountains in the U.S. and
Yeah.
if you're doing that through the snow and you know that the road is clear, that is an amazing benefit.
Yeah. The real test is going to be, does it work up in the Rockies? Does it work? So the other thing is, does it work in with pressure changes, in atmospheric pressure changes too, if you think about it, right? So because boiling point changes with atmospheric pressure. So is this more effective or less effective at a higher elevation?
Yeah, and they're saying the researchers say the ability to prevent concrete surface from dropping below freezing will help prevent its deterioration. So, uh, I guess the question becomes: is this combined with other technologies we talk about, like some of that heat transfer technology,
Mhm.
for colder? Will this actually um, extend the life and maybe give us roads that aren't frozen all the time?
I think so because, well, that's the thing too. The other thing that you have to think about is that water gets in. So I think the paraffin wax kind of acts like
Sealant,
um, a sealant, but also like not an insulator, but if you like, so
magnifying glass.
it enables the concrete to have some movement, if that makes sense, so that it's less prone to cracking. So it kind of like a filler, but not really a filler. But I don't know what it actually looks like. But so by allowing it to have some leeway, some give, I think definitely super far lasting. And I don't know if construction companies are going to like this too much, because they like that they get to repave and do things more often than not, because they make more money that way.
Yeah, but you just got to take a step back and say, wait a minute. You can say, oh, I don't want to do that, but uh, yeah, you do, because now you got to spray the roads with paraffin wax as part of your treatment. It's a whole other thing. Every year, every 3 months, you got to spray the wax down on the to make sure it's on the roads. Otherwise, because cars are driving on these things and it's coming off.
I don't. So there's the thing. I don't know if it's sprayed on top or if it's actually integrated into the concrete mix itself.
Well,
That's what I thought. But now that you're saying the spraying, that potentially, but um, I thought that it was built like as you lay the concrete mix itself has the paraffin wax kind
I
of built
could
into this to
that,
the structure.
that could be the case. I'll continue
I don't
looking
know
through
that, but
for.
like, see that picture there. Oh no, that's a
Yep,
snowboard.
that's
But
a snowblower. So I'll keep checking this out because I thought it was the research to prevent concrete. This is I just feel it's a similar principle. Like I had we got to switch to the next topic soon. I had or this is last topic,
no,
so
this
we're
is the
good.
last one.
Yeah, good. We're good. uh, Coffee the other day with a little bit of coconut oil in it, and I stirred it
Yeah.
up, and I didn't pay attention to it, and I put my hand over it. I didn't feel any heat coming off, like didn't feel too hot, so I went to take a drink, but the slight air layer of coconut oil on the top stopped the heat from coming out. The coffee was still boiling hot and burnt the inside of my mouth, and I'm like, you can't feel it, like it's
Yeah.
been sitting there for a half hour and it's still that hot. So you got to wonder if it's similar principle where it's just
Yes, maybe. Yeah.
trying to keep that away. So I'm gonna take a look here while
Yeah.
I say
The only like the problem that with this is I think paraffin wax is an oil byproduct or
yeah,
a petroleum byproduct.
it's not
So
biodegradable. It's
not the best.
not
But they
environmentally
are, like,
friendly.
as you're doing a search, they are looking at other potential alternative phase change materials. So one is fatty acids. So materials like stearic acid have melting points in the desired range. Salt hydrates, polyethylene glycols, agar, bio-based waxes. So that could be better, like soybean or canola. Um, so shape memory alloys. So that's kind of like the phase change things that we were talking about before. Hydrated salts, organic fatty acids could even work too. So there's a bunch of this is just I think this is we're just on the cusp, on the precipice of this.
So there's two ways that they've tested this. One is coating small pebbles with paraffin and then putting that in the concrete, and then or putting micro capsules of paraffin were mixed
That's what I thought.
directly
Yeah.
into the
Okay.
concrete.
Yeah. Yeah.
Um, so that I unfortunately, again, paraffin wax, I don't know. They test this at low temperatures. Do they test it at high temperatures? Because does that stuff melt and disappear when the road hits 100 degrees?
Yeah. Like what's going to happen because climate change, right? And we're getting hotter
Well,
and hotter. So
you're talking about literally concrete or maybe black tar on top or whatever, where the sun is hitting on it. You've never touched the road or whatever in a summer day and like, holy crap, that's hot. This is exactly what we're talking about. So I'm curious as to the longevity. I love what we're doing here. And if paraffin wax will do it, what else will do it? Right. That's why I'm encouraged by it.
yeah,
It would be nice to see what kind of alt environmentally friendly alternatives, like we were talking about using those shrimp shells to make leather,
yeah,
which is a great solution. What else out there can we use to make a paraffin wax type replacement?
Yeah. And just going back to your comment about the oil, and there's a comment from a LinkedIn user, says, reminds me of a story I heard yesterday. Scotch on the rocks comes from using chilled rocks during ice unavailability. So interesting, but
Yeah, that's probably true.
yeah.
They use like stones and or metal and stuff now. You can buy those little kits that you
Yeah.
freeze instead of
And then
ice,
it
so it
doesn't
doesn't.
water it down because
Yeah.
that's sacrilegious, apparently. I'm not a big Scotch drinker, but
Thank you for the comments, LinkedIn user.
yeah, I
It,
appreciate the interaction, guys.
yeah, this is great. Like, I think we would all love to be able to get out, brush our car off and go and
Yeah.
have the snow automatically melt off the thing and not have to worry about plowing our driveway.
It would be nice that if our cars would just melt the ice and snow, if we had phase change metals or heat up, and the glass itself could heat up. That would be cool.
Absolutely. And again, some of those technologies we have about those thermal ribbons and whatnot look like they might give us some direction there. And I think it won't be long till they're incorporating solar into cars to do exactly that kind of thing. Is that
Well, the
what?
one that does that, and it's a huge failure though, is Fisker. Fisker incorporated solar panels into the. I think actually Tesla does it too, but Fisker was the first to do it. Incorporate solar panels into their cars.
Yeah, I imagine this is going to be a long,
Oh yeah.
a long run. I love solar and I love where it's going. It's just not super efficient right yet.
No.
And like Amazon shut down all their solar stuff and removed it from the warehouses because it was blowing up and going on fire. And that just might have been the manufacturer and stuff they had. But when you take a look at this and say, all right, we're using more and more electrical stuff in cars. So why wouldn't we try and have some solar panels on the hood or on the trunk or whatever that's non-reflective, or even on the top, that would help melt the windows, that would help melt
Yeah.
the mirrors to keep them warm, to keep defrost while you're that kind of stuff.
And obviously not to charge our EVs because we're talking about hydrogen powered cars, right, Craig?
Ideally, that would be long term, but like you're still using power, and like the whole point is
Yeah.
that it'd be great to if we're using hydrogen power, that's great. But wouldn't it be nice if you click a button on your car and it uses those solar panels to automatically melt the ice off your car?
Oh yeah. No, I totally agree. Sorry, I had to get that dig in for EVs. That's why.
Yeah, of course, of course. All right. Any last words on this?
No, this is great. This is sorry guys for speeding through this today. We had a little bit of a hiccup, and yeah, no, this has been a great discussion for sure.
Yeah, I'll tell you what happened. We pressed start. It didn't start. When I set this up yesterday, there was a problem with StreamYards and YouTube and stuff, so things didn't work. Hey, thank you, LinkedIn user. Appreciate it. Appreciate
Yeah.
you being here. John, what do you got going on?
Well, I'm not going to it yet, but OCI Discovery X is next week. Should be a phenomenal conference. I think it's 2 days in Toronto. But that's I've got. Oh, there's a fractional dinner that's been organized by Ryan Wong coming up this April 25th, which is going to be really cool. He does some really good events. He does some generative AI events and different things. So really cool stuff. There's a post on LinkedIn that I posted about it. If you have any questions, reach out to me. And then on May 2nd, but we'll be talking more about it, but might as well plug it now. We've got Startup Drinks, which I'm excited for. I always love that.
Yeah, Startup Drinks CO on May 2nd. We've already got like 40 tickets sold, so it's going to be a good one. If find out more at TorontoStarts, all our podcasts and events and whatnot go up there. I'll be launching new courses and coaching programs soon. If you're stuck in your business and want to move forward, go to startupcoach.ca and book a discovery call. I'm launching some new courses to teach knowledge workers, busy professionals, technical gurus how to turn their knowledge into a high ticket course. So look for that coming soon, and basically teaching people how to productize their knowledge.
Perfect.
And if people wanted to, let me see. Oh, that's a ticker. Never mind.
That's
They
fine.
should reach out to you on LinkedIn.
Yeah.
for anything funding related?
Anything funding related. Yeah, there's always new funds coming out. There's a new one by OCI that just came out. If you're in the construction field or critical technologies, there's a new one that just released. It's a new program. It's a 2-year program. Feel free. It's for housing and different things like that. So, yeah.
That's John Irwin on LinkedIn. And we got one last comment here. Quasars and black holes remind me of charges and spins. I wonder what the difference is. So maybe one is definitely a megastructure. We talked about glowing black holes last week.
Yeah. Yeah, so that's a great comment. Feel free. We talked about in depth in our previous podcast, and this is episode 22, I think. We've got 21 other episodes on Spotify and on Apple Music and on YouTube. Go ahead.
Yeah, so that's not exactly accurate. So we've recorded 22 of these, but after about 4 episodes, I started breaking them up into each. We cover 3 topics, and there's 3 episodes per. I think we're around episode 30 on Spotify, and but yeah, you're
Right. I underestimated. I apologize.
No, it's all right. It's okay. Thank you, everyone. Check out the Future Tech Podcast on Apple Podcasts or on Toronto Starts, and we'll talk to you all soon.
Thanks, guys. Have a great day.